Hi, let's see one of the question on indexing. A data file consisting of 1,50,000 student records is stored on a hard disk with the block size is 4096 bytes, right? So as the it is a kind of some lengthy question. I will try to write in the form of points better. So total number of records are 1,50,000, right? And the block size they have given as 4096 bytes, right? The data file is sorted on the primary key roll number. The size of a record pointer for this disk is 7 bytes, meaning that they have given clearly a record pointer size. Record pointer size is 7 bytes, right? Each student record has a candidate key attribute called ANum of size 12 bytes. So here they are simply saying that candidate key size is 12 bytes, right? Suppose an index file with the records consisting of two fields. This logic you know. Why two files? ANum value and record pointer. So they are saying that simply an index file which contains one field is ANum value, another field is a record pointer. The corresponding student record is built and stored on the same disk. Again they are going to be stored. Again the index file is also going to on the same disk. That is what they are saying. Assume that the records of the data file and index file are not split across disk blocks. What is the meaning of this one? It is of type unspanned. The number of blocks in the index file is what they are asking, right? So guys, you know, if it is a kind of a hard disk, it is going to have a hard disk, and once you mention it contains certain data as per the given question, you need to clearly understood it's a kind of secondary indexing, guys. Secondary indexing, because here they are trying to take some sorting on primary key, but in the indexing file they are trying to take one more kind of a candidate key, not the primary key roll number. They are taking a number, right? So this particular concept we can call it as secondary indexing. And you may think if it is a kind of a secondary indexing, that data is going to be in an ordered file. If you want to have the clarity, you can just go through the LED videos. The data is going to be an ordered file, right? Now in second indexing mechanism, number of index records is equal to number of data records, guys. Am I right? Because this data is in unsorted order, so I am going to simply place in them in a sorted order. Right? So now, right? So how many index records are going to be there here now? Total number of index records are going to be available as 1,50,000. 1,50,000, right? If here it is going to have 1,50,000, how many blocks are going to be stored per block? Right? Simply we can write as block size is what? 4096. How many? What we can say? What is the record size? What is the index record size of the index file, which is record pointer size plus key size? 7 plus 12, 19, which is equal to, if I calculate 4096 by 19, so which is equal to 215.5 around something, right? So I can say that it is going to have 216 what? 216 are going to be placed, or 215 are you going to place, right? You are going to place only 215, which should be floor, right? Because I cannot able to place more amount of data other than 215.5 in a particular block. So in a particular block I can able to place 215 index records. 215 index, right? If I am going to place 215 index records, I would like to place 1,50,000 records. 1,50,000 records. Then how many blocks are required? 1,50,000 by 215. Then you are going to get 50,000 by 215. So which is around 697.67. So definitely I required 698 blocks. 698 blocks, right? As you required 698 blocks, you require 698 blocks. Actually, if I am going to apply binary search algorithm, the total number of block access are log 698 base 2. Block access at the index level, it is log 698 base 2. Okay, but here the question they have asked is simply the number of blocks in the index file. That's it, right? So how many number of blocks are there in the index file? 698. So answer will be the 698. Right? I hope you understood clearly. Thank you.